Hello, welcome to FM Tuition Academy. Remember, this is teacher Frank the Genius, the GCE surgeon himself. It doesn't matter where you're watching me from. You know you are somebody who is writing or planning to write GCE, whether it's mathematics, physics, English, chemistry, biology, civic education, any subject that you are writing. You know you are somebody who wants to write GCE. Maybe you didn't do well in your exam, or maybe you have written GCE before and you didn't do so well. We'll be able to help you. Our tuitions are tailored with examination past paper revision. This will help you to get a merit or a distinction. Allow us to help you. If you know you really want a one-on-one interaction where you are taught with excellence, comment your WhatsApp number and our team will get a hold of you to help you to boost your performance to a level where you're going to pass. So it doesn't matter where you're watching me from. Don't worry about it. Just comment your WhatsApp number and we'll teach you. So today in chemistry, we'll be looking at a topic entitled ions. We'll be looking at a topic entitled ions. So we're looking at a topic called ions. Ions. This is the topic that we're looking at. The first thing that you need to ask yourself first is, what is an ion? What is an ion? So they can ask you that in the exam. An ion, let me just start it from here so that you can understand. An ion, it is a charged atom. An ion is a charged atom. It is a charged atom. An ion is a charged atom. An ion is a charged atom. Okay? What do I mean when I say charged? You already know what an atom is. An atom is the smallest particle of a substance that can take part in a chemical reaction. We did that in the first topic. So this is a continuation of what you have done. So what do I mean when I say charged? Meaning it is electrically charged. Electrically charged. So meaning either, so if they ask you to define an ion, you define it like this. So the atom is electrically charged. Okay? It is electrically charged. Either positively or negatively. So an ion is a charged atom. What do I mean when I say charged? Meaning it is either positively charged or negatively charged. Okay? So it can either carry a positive or a negative. That's what an ion is. An ion is either positively charged or negatively charged. It is a charged atom. The atom is electrically charged. It's either positively charged or negatively charged. Positively charged, let me put it like this so you can easily understand. Under ions, there are two types of ions. There are two types of ions. The first one is what is called cations. The second one is what is called anions. Anions. When I say cations and anions, what do I mean? So, positively charged ions or rather positively charged atoms are called cations. Okay? Positively charged atoms are what you call cations. So when I say cations, I mean positively charged atoms. Okay? And then negatively charged atoms are called anions. Okay? Cations are positively charged atoms. When an atom is positively charged, meaning it carries a plus, okay? Positive, a plus. When an atom carries a positive, it's called a cation. When an atom is charged negatively, when it's charged negatively, is called an anion, meaning a negative charge. It carries a negative charge. Okay? That's a little about that. So, to further explain, I'll continue again. I'll wrap this so that I create space just for you to get the basic ideology. Okay, just for you to get the basic ideology, guys. This is to help you to get the basic concept. Okay? Let's hope you're writing the notes, because they can ask you to say what are cations. Another way is cations are positive ions. Anions, they are negative ions. Okay? That's what I mean. Cations, positive ions. Anions, negative ions. Okay? So let's go ahead and what do I mean, so that I can explain so that you understand. When I say positive charged, what do I mean? When I say positive charge, what do I mean? Positive, it means the atom has lost electrons. So positively charged ion, what does it mean? A positively charged ion, what does it mean? It means the atoms has lost electrons. What about a negatively charged atom? What does it mean? Meaning, it means the atom has gained electrons. Okay? So, when an ion is positively charged, meaning it has lost electrons. Why? Because it is positively charged. It means it has given out electrons. When an atom is negatively charged, it means it has gained electrons. Positively charged plus, it means losing electrons. Negatively charged minus, it means gaining electrons. So that's what I mean. Okay? So we have picked some few points. Why am I teaching you short things? Is because we are not like teachers. We are more of tutors, meaning we teach you what comes in the exam. So we go to the main important things that come in the exam. Okay? No wonder the notes are very summarized, just for you to understand, and then you proceed. So that's it. That's it. Okay. Now, example. I'll write a table. I'll write a table here. So I'll write this table. Look at this table. So I'll write a table for the equations. Okay? This is for the table for the equations. This is a table for the equations. For the equations. Table for the equations. Meaning it has lost electrons. Okay? Equations. Equations, it means it has lost electrons. Positively charged. So examples of equations. So I'll write here equations. The first equation I can put is sodium. I'll write it like this. So write a table like this. So that here I'll put item. Here I'll put the word item. Equations. Here I'll put electrons lost. Okay? So the item number 1. If I say sodium, you remember the symbol for sodium is Na? I taught you this. So its ion for sodium, the ion for sodium looks like this. Now, I'll teach you the way I'm coming about this. Don't get confused. I'll teach you the way I'm coming about with the ions. Okay. So sodium, it is written like this. This is the way the sodium ion looks like. Sodium 1 plus. Okay. Magnesium Mg2 plus 3. I can pick even 3. The other one that I can pick is sodium, magnesium. I can pick calcium. Ca2 plus. So what does 1 plus mean? 1 plus I mean losing electrons. So whenever you see an ion which has got a plus, it means it has lost 2 electrons. It has lost an electron. When you see plus, it means losing an electron. When you see minus, it means gaining. So sodium atom 1 plus, it means it has lost 1 electron. Magnesium, its symbol, the ion for magnesium, it's 2 plus. It means magnesium has lost how many electrons? 2 electrons. Whatever number is here, that's the number of electrons that's lost. Calcium 2 plus. It means calcium has lost 2 electrons. That's what it means. If I write 3 plus, it means calcium has lost 3 electrons. So plus means to lose electrons. Okay? Positive O plus, it means losing electrons. Okay? So I'm writing that to help you understand. I'm teaching you the first way of understanding chemistry to help you get a distinction. Okay? So that's how you do it, guys. So these are cations. These are all cations. All cations, and cations are all positive. So all cations are for positive charges. How am I coming with 1, sodium 1 plus, magnesium 2 plus, calcium 2 plus? Don't worry, I'll teach you as I'm going. I'll teach you so that you can know how to do this, to open your mind. But this is the way they appear, even in the exam. When you see a positive in front, or it's like a power, you see an atom, it has got a power. Either 1 plus, 2 plus, 3 plus, 4 plus. Such atoms which have got pluses, they are called cations. Cations, or positive ions. Okay? Positive ions or cations. That's it. Okay. Let's look at the other table is going to be for anions. I'll wrap this. I write now a table for anions. Okay. So anions, on the other hand, anions, this is a table for anions. Anions table. Anions. Anions, it means negative. Now anions always carry a minus, right? So anions means they carry a minus. Minus. Okay? A minus or a negative. That's what I mean. Why am I writing this for you so that you can remember? Minus, it means to gain electrons. Gain electrons. I explained that in the definitions. So anions, these are atoms that have gained electrons. Okay? Anions that have gained electrons. Atoms that have gained electrons. Anions, these are negatively charged ions. Like I said, anions are negatively charged atoms, or anions are negative ions. Okay? Negative ions. Okay, so examples of negative ions will include oxygen. How do you write the ion? 2 minus. I'll tell you how these are coming about. So electrons are gained. In here it's gained, it's different from the first one. The first one was lost. So anions, so I'll put anions there. I'll put sulfur. Sulfur S, 2 minus. Apart from sulfur, I'll put fluorine, F, 1 minus. That's how it looks. F to the power, these are like powers, okay? Powers. Oxygen to the power 2 minus, sulfur to the power 2 minus. So what do I mean when I say minus? Minus, I mean it has gained 2 electrons. So these ones on top are called electrons, okay? These powers are electrons, these powers are called electrons. So 2 minus, I mean it has gained 2 electrons. 2 minus, I mean it has gained 2 electrons. Fluorine, 1 minus, it means it has gained 1 electron. It has gained 1 electron. That's how you deal with this. So this box is for electron gained. All this electron gained. Okay. But how do we find these ions? I'll show you a demo so that you can understand. Okay. I'll wrap this. You can write that. Okay, let's go to the second segment of the same part so that I help you to understand. Okay. If I say write the ions for the following atoms. Write the ions for the following atoms. Write the ions for the following atoms. Remember, use a big handwriting so that you can see. Write the atoms for the following. Write the ions. Write the ions for the following atoms. We are writing the ions for these atoms. I'll pick the first one. Sodium. Now, sodium, abbreviated as Na. How do you write the ion for this? I want to show you how those ions are coming about. The first thing, you need to know the electronic configuration of these elements. In the exam, they'll provide you a periodic table. But since you are just beginning now, I gave you the first 20 elements. Know those 20 elements by heart. You need to know the atomic number for these. Always master, in chemistry, to pass chemistry, master the atomic numbers. You will use atomic numbers whenever you are dealing with most of your calculations in the entire chemistry until you write your exams. Memorizing the atomic number, this will help you. I want to produce geniuses, not people who are just depending on the tutor. So, master the atomic numbers. In the first 20 elements, I told you the 20 elements and their atomic numbers. The first one is hydrogen, atomic number 1. The second one is helium, atomic number 2. The second one is lithium, atomic number 3. The fourth one is beryllium, atomic number 4. 5, boron, atomic number. 6, carbon. You see, you master them up to the last one, which is calcium, 20. Know it by heart. Be a genius. The way you mastered your multiplication table, master this. So sodium. Sodium. Atomic number for sodium. This is already written here. You say sodium atomic number, it is 11. You write what is called the electronic configuration. Electronic configuration. Electronic configuration. From the previous lesson, you learned how to write electronic configuration. So I'll continue based on the previous lesson you did on electronic configuration. How do you write an electronic configuration for this atomic number? The first shell has got 2. So 2, comma. The second shell should have 8 and less. In case you didn't do the electronic configuration, I'm redoing it here just to help you to understand. The first shell should always have 2. The first shell should have 2. So if I've got 2 here, the second shell should have 8 or less. 8 or less. First shell 2, second shell 8 or less. So if I put 2 here and then I put 8 here, 2 plus 8, it's 10. So 10 minus 11, only 1 will remain. So third shell will have 1. Have you seen the way I've done it? Have you seen the way I've done it? How do you write electronic configuration? The first number here will be 2. So what do I mean? Once you put 2 here, it means the first shell of the atom has got 2 electrons. So these are called shells. The first shell, the second shell has got 8, the last shell has got 1. So when I put 2 here, it means in 11 I've removed the 2. But I know that the number that follows should have a maximum number of 8, not above 8. It can have 8 maximum or less. So if I put 8 here, if I add 2 plus 8, I have 10. Meaning to reach 11, I need 1 more. So the other one will be put in the other shell. That's how I'm coming about this. So, how do you write the ion now? How do you write the ion? So, when writing the ion, you look at the last number or the number of electrons in the last shell. You focus on this last number. You focus on the last shell. The number of electrons in the last shell. If the number of electrons in the last shell, so I'll write here, if the number of electrons in the last shell is less than 4. For example, if the number of electrons here is less than 4, maybe it is 1 or it is 2, maybe it is 1 or 2 or 3. These are less than 4. So if the last number here, the number of electrons in the last shell, it is 1, it is 2 or 3, meaning less than 4, you will write it the way it is. Meaning the ion will be positive. Meaning the ion will carry a positive sign. If the number of electrons in the last shell, this one, if the number of electrons in the last shell is less than 4, if the number at the end here is less than 4, if the number at the end here it is 1, 2 or 3, you write it the way it is, but it will carry a positive. So meaning the ion formed, the ion that we are going to form here, the ion that we are going to form, the ion formed will be, the ion that is going to be formed because of space. Where can I write it? Okay, maybe here, I don't know if it's visible. Okay, let me put it here. Okay, I'll write it here. The ion formed, the sodium ion, will be like this. Sodium ion. Because the last number is 1 or 2 or 3, you write it to the power 1. Since it is less than 4, it will carry a positive, meaning it will be 1 plus. That's where it came from. Okay? 1 plus. So meaning this ion will be sodium 1 plus. That will be the last number here. It is 2. Meaning it will be sodium 2 plus. If it is 3, sodium 3 plus. Only if the last number here is less than 4. Okay, I'll wrap this. Let me look at another example. This statement will still remain. Just for you to remember. Okay, let's look at another example. Instead of sodium, we are looking at another element. Let's say magnesium. Magnesium. So magnesium So magnesium, which is abbreviated by Mg. Atomic number for magnesium, it's a symbol for magnesium. Atomic number is 11. So what do I mean? So magnesium has got 11 atomic number. 12, sorry, not 11, 12 atomic number. Magnesium has got 12 atomic number from the periodic table. It has got 12. So electronic configuration, you write the electronic configuration. The first shell always has 2. So when I remove 2 here, if I remove 2 from here, how many electrons have remained? 10. Because it's 12 minus 2. 10 has remained. But I know that the second shell should have either 8 electrons or less. So meaning if I put 8 here, this plus this is 10. So it means this will work. Because this plus this is 10, meaning the last shell to make 12, I'll put the 2 on the last. So the first shell always has 2 or less. The second shell has a maximum of 8 or less. Don't put 9 here. Don't put 10. Maximum it can go is 8. It can either be 8 here, 7, 6, 5, 4, 3, 2, 1. Meaning here the maximum it can go. The second shell, the third shell, the fourth, the fifth. Any number of shells that follow should always have a maximum of 8 electrons or less. It can either be 8, 7, 6, 5, 4, 3, 2, 1. So I said you focus on the last number, the number of electrons in the last shell. If it is less than 4, like I said, less than 4, less. Can you see the last number? Is it less than 4? Yes. So meaning the charge will be positive on the ion. So meaning the magnesium ion will be magnesium 2 plus. That's how I'm going to write it. Magnesium 2 plus. This is a magnesium ion. Have you understood? That's how you write these ions. Okay? What about for negative ions? Okay, what about negative ions? I've wrapped for magnesium. What about a negative one? You see, the ones that we're dealing with was positive ions. These were positive ions. Okay? So this rule applies for when the charge okay, let me wrap. I'll give you other ions. I want you to look at the differences. Okay? This is if the last number is less than 4, it will always be negative. If the last number is less than 4, it will always be negative. So this is the first rule. The other rule, what about if I put sulfur, for example, or oxygen. We are writing the ion for oxygen. Atomic number for oxygen is 8. Electronic configuration. The first shell should always have 2. So I'll put 2 here, comma. 8 minus 2, what has remained? 6. I'm going to put 6 here. I told you, this shell should have 8 or less. So it means 2,6 will still work. Because here I can't put 8 because 2 plus 8 will be 10, but this one is 8. So only 6 fits. It should not be more than 8 or less. So, have you noticed the difference between this? I said to write the ion, you focus on the last shell, this one. That's what I said. The last shell. What number do you see? Okay. If the last number here, it is above 4. You see, the ones that we are dealing with was below 4. Below 4. No wonder it was positive. But if the last number is above 4, it is negative ions. So, the same rule, but to apply now, I'll write another rule again. So here is the other rule. If the number of electrons in the last shell is above, e.g., what do I mean when I say above 4? Meaning if the last number here, it is either 5, 6, 7. If the last number here is above 4, it is either 5, 6, and 7. Meaning the ion formed will be negative. If the last number is above 4, the ion formed will be negative. If the last number here is above 4, the ion formed will be negative. So, what do? I want to form the ion for this one. I look at the last number. So, the last number, if it is above 4, the ion form will be negative. You subtract the last number from 8 to get the charge. So, the other point you need to know is you subtract from 8 the last number. This last number is subtracted from 8. So what you're going to do is you say 8, the last number is subtracted from 8, which will give you 2. So you will use 2 for your ion. So meaning oxygen ion, it will be oxygen ion 2 minus. This 2 is what you're going to put here. You are not going to put 8. You're not going to put 6. Okay? I hope you have understood the difference. So this is the ion for oxygen. I repeat. You first write the EC, which is 2,6. Then you look at the last number. If this last number, guys, if the last number here, it is above 4. If it is above 4, this one, the last one, it is either 5, 6, or 7. You will be subtracting it from 8. Always subtract it from 8. 8 is called the stability number for all electrons. So you always subtract from this 8. because the maximum number of electrons a shell should have should always be less, should always be 8 rather. So it means whatever number you're going to get here, as long as it is above 4, it is either 5, 6, 7, you subtract it from 8. So if it was 7 here, it would be 8 minus 7, 1. So here it would be 1 minus. If here it was 5, it would be 8 minus 5, meaning 3. So meaning it would be 3 minus. That's how you deal with this. Okay? Okay. That's a little about the ions. Now I'll wrap this. Please remember these rules. This is rule number 1. Rule number 2, this is rule number 3. Rule number 3 goes together with rule number 2. Okay? Rule number 3, this one where you're subtracting from 8, it is only applicable for the ones that are above 4 only. So rule number 3 and number 2, they are mixed. No wonder I've written them. I've written an arrow like this. Rule number 3 and number 2, they go together. Okay, so this is the way the ion for oxygen looks like. The ion for oxygen, 2 negative. What about if I say, I give an example, they say another element would be fluorine, for example. Fluorine. Fluorine, it is its atomic number. Abbreviation is F. Atomic number for fluorine is 9. So EC, electronic configuration, is 2,7 because the first shell should have 2. 2 minus 9. 9 minus 2 rather, it is 7. So it means 7 has remained after we remove this. The second shell should have a maximum of 7. Maximum of 8 rather. So it means 8 or less. So you check the last number here. The last number, is it above 4? Yes. This last number, is it above 4? Yes. So meaning now you subtract from 8, which will be 1. So meaning you use 1 as a charge, but it will carry a negative. So it will be fluorine 1 minus. I hope you have understood. That's a little about the ions. Let me give you an exercise now. Okay. Okay, let me give you an exercise for this same. So we are writing now the exercise. Okay, right there. So this is the exercise. Okay, this is an exercise. This same thing, the same question, but it's an exercise. Right? This is now the exercise. Exercise. Okay, write the ions for the following atoms. 1. The first one is the first one that we're going to look at is aluminium. Aluminium 2. The second one I'm going to look at is potassium. Potassium 3. We're going to look at calcium. 4. We're going to look at chlorine. 5. We're going to look at phosphorus. Check these from the 20 elements to check their atomic numbers. Use the atomic numbers. You write the EC, then you check. You check the last number in the EC. Is it below 4? You write it the way it is, you put a charge of positive. If the last number is above 4, after you write the EC, electronic configuration, if the last number is above 4, you subtract from the stability number and then you carry negative. Okay, so this is the first question. Okay, I think this is enough. Let me just give you this exercise. This is enough for you. Okay. Until then, keep enjoying yourself with online tuitions. Those ones want to do tuitions, comment your WhatsApp number. We'll be able to help you. So this is a lesson concerning ions. I love you all. This is teacher Frank the Genius signing out. All right, we've come to the end. Listen, you can start writing that exercise.